Today we'll start with topic sequences of real numbers. The concept of sequences is very essential in analysis because in mathematics, if you go to higher mathematics, then most of the things can be proved using sequences, and you can understand many situations, physical situations also using sequences. Right. So, so where do we come across sequences? And so there are several occasions in real life situations where you can use sequences. Right. So, for example, if you have discrete data, right? So if you have a discrete data, and so where that data, so what is the trend of particular data? So data could be about economical situation, data could be about environmental, uh, 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 environmental behavior. So data could be about rain, the monsoon behavior. So there are various lots of data available. And the main problem, what data scientist or what is going on in data science? So you have lots of data and you have to analyze. You want to analyze the data. And what is the trend of particular data? Where it is trending? Where it is going? So what trend that particular data sets? So these kinds of things are there in physics, electronics, chemistry, data science, computer science, right? Environmental science, everywhere. Medical science, lots of data is available there, and you have to analyze. You want to analyze. And so why we are doing this mathematics in BSc? Because we are basically doing very fundamental mathematics, basic mathematics, right? And the first step is to understand fundamental concepts. In previous topic, real numbers, we try to understand the fundamental properties of real numbers. Right. Now, using those fundamental properties, we can understand some more properties. So this is a way we are developing our mathematical knowledge, and then we in future we will be applying this knowledge to solve the many problems which are there in day-to-day life, right? So from physics, electronics, whatever, statistics. So the fundamental tools, and then the basic knowledge or basic concept is the knowledge of sequences, and what basically sequences, and in what sense sequences are useful in mathematics, in analysis, or in science also. So now we want to learn. So our approach is to understand mathematical point of view, because our knowledge is, we are more emphasis on mathematical. So how mathematically this deal with this particular concepts, and then later on you can understand how it is useful in solving real life problems. Okay, so what is a sequence? So if you might have studied the concept of sequences earlier, right? So okay, so sequence means what? It is just subset. It is a arrangement of real numbers. Arrangement of real numbers. For example, if I want to arrange real numbers, 1 by 2, 1 by 3, 1 by 4, and so on. Right? So these are the numbers. Now the numbers means positions are fixed. Positions of these numbers are fixed. This is the first number, right? So numbers and positions, or at first position the number is 1, right? At second position number is 1 by 2. At third position is number is 1 by 3. At fourth position number is 1 by 4, right? So in this way, what will be the number at 10th position? What would be number at 10th position?
1 by 10.
1 by 10, because there is some pattern here. so that you can predict. But not necessary that there is a pattern, but most of the times will having some pattern, and from that pattern will have the terms or numbers. So for look at, this is one example, this is second example. If you have positions or place or steps and numbers assigned to that position. So one positions. So positions are are what type of numbers?
Real numbers.
Natural numbers. Positions, right? At which point? First position, second position, third position. So positions are natural numbers. Remember this. And the numbers assigned to those positions are uh, real numbers. So I can have 7 by 3, then 0, 1, 5 by 9, right? So these are numbers assigned to the position. But here is no pattern that we can identify easily. But you can assign numbers to the positions. And how many positions? Positions are natural numbers, right? So positions are
Yes.
natural numbers, and the numbers assigned to positions are real numbers. Correct?
Yes,
And
sir.
we cannot interchange. Once we there that these positions. So this is 7 by 3 as the first position and 0 at second position. 1 is at third position. 5 by 9 is at fourth position. So we cannot interchange the positions. Remember, once their positions are fixed, we cannot interchange. And then the question is, what is happening if you go to the higher position where these numbers are tending? That is our main issue, right? Because how many positions are available? How many positions are available? Infinite,
Infinite.
right? And therefore, if you go to higher and higher positions, 10 position, 11th position, and so on, 100th position, where these numbers are going, because these numbers are not easy to see, right? The numbers assigned to the position could be the complicated thing. Right. So mathematically or technically, how to state this phenomena? So you know that what is a function? You know definition of function. You know definition of function. Let
Yes, sir.
A and B be non-empty sets. Are you which the PDF I have provided of algebra chapter 1? So from that you can get all detailed knowledge about function. But I am assuming that you have read that PDF, and then I am directly telling you the definition, and I will go ahead. So a non-empty sets of function f from A to B is a relation, right? From A to B. That means we are going to relate elements of A with elements in B, such that for every element x in A, there is unique element y in B, such that for every element x in A, there is unique y in element B with xy belongs to f. When I say f is a function and function is a relation, that means the pair xy is in f, means x is related to y with respect to this relation. That is fx is equal to y. That means we are assigning elements of A with elements and B. And what are the important words? Every and unique. These are two very important words. Then only it is function. If this fails, key for every x and unique y, if it fails, then that is not a function. Remember this. right? So do you understand this? Any doubt about definition of function or any difficulty?
No, sir.
Very good. So you can understand this easily. So for example, if my set is A, B, C, D, and B is 1, 2, 3, 4, and if I define a function f of A is equal to 1, f of A is equal to 2, f of B is equal to 3, f of C is equal to 4, f of D is equal to 4. So is it a function?
No, sir.
No, sir.
Why? What is
So
the
the
reason?
unique
Because
number.
f of a is related to two elements in B.
Right. So A cannot have two distinct images, but here there are two images distinct. That is not possible. Two distinct elements in domain can have same image. That is not an issue, right? Like a gun, you can fire two bullets at same point, but you cannot fire single bullet at two distinct points. So that is what the definition of function. So now go back to our previous discussion. What is the assignment? I am assigning positions with real numbers, and what it is looking like, I am relating natural number with real numbers, right? Do you understand? I am assigning real numbers with positions. Positions are natural numbers, and to these positions, because I cannot change the positions. Once I am saying that this is my assignment of real numbers with positions, I cannot change. So this is assignment or relation. I am relating natural numbers with real numbers. So what is therefore sequence? Right? So sequence, a sequence of real numbers is a function x from natural numbers to real numbers. So sequence of real numbers is a function from natural numbers. So n corresponds to position. So to, and if you recall the definition of function, right? So if you recall the definition of function, right? For every element in domain, we are assigning unique element in codomain. Right. So that means for each position, each natural number, we are assigning real number. That is what the definition of sequence. So, for example, if I define x function from natural numbers to R, x of n is equal to 1 by n, right? Then x is a sequence of real numbers. So x is a sequence of real numbers because each natural number, and therefore, if you look at the images of particular elements, then in this particular case, domain is uh, domain is natural number. So what is x1? What is x2? What is x3? Right. So let me please keep your mic off. Who has kept mic on? Arun. So So at what number is assigned to first position is 1, right? What number is assigned to second position? Number assigned to second position, that is x2. What is it? Do you understand? Right? N, what number is assigned to position n? 1 by n. Correct? Is it correct?
Yes, sir.
Yes, yes.
So 1 by 3
Yes.
and so on. So in this way numbers we are assigning to the natural numbers. Right. So if you look at another example, x of n is equal to 2n plus 7 divided by 5n minus 1. So this is a sequence because I am taking domain as a natural numbers and I am getting real numbers, no matter what real numbers we get, but we get real numbers. And therefore, what is x of 1? What is x of 1? 2 plus 7, 5 minus 1, so 9 by 4. Right, what is x of, what is second
Sir,
number?
domain should be n belongs to n minus 1 by 5.
1 by 5, but 1 by 5 is not natural number, so don't worry.
Okay, sir.
Right, if my, in the denominator, if there is n minus 1, then I should worry about like this. Correct?
Okay, sir.
So what is second number assigned to this? 4 plus
11
11.
by 9.
11,
24.
11 by 9. Okay, so you can understand now what is this. So if x from R is a sequence, then then for n belongs to natural numbers or in domain, we denote x of n by x suffix n. Right, so now you understand this is a notation. When I say ki image of this function, image of n under this function, so what is the number assigned to n? Right, that we denote by xn, called as nth term of the sequence x. So our sequence was this x. Our sequence was x, and we denote x at n, right? So number assigned with n by x suffix n. This is a notation, right? Nth term of sequence xn. So we write sequence x is equal to xn, or these are the notations used in various books. So no matter, the meaning is same. Xn. Xn means the all terms xn. So when I say x, when I say x means what? That is, when I say x, x means what? This function or this sequence. And when I say function means the at every element in domain, function is different. So function gives information about all the elements. That means it is actually x1, x2. So this x gives information about all the images of elements in domain. So therefore, it, when I say x, then it gives complete data. Okay, what is x1, what is x2, what is x3, and so on. And therefore, what is it? That means what is xn? What is xn? x1. What is x1? We denote by x suffix 1. What is x at 2? Capital X at 2 we denote by small x at 2. Right, so this is a notation. Therefore, this is same as this is same as this. X at 2 is same as x2. Right, and x at n is denoted by x suffix n, and so on. And therefore, sequence has infinitely many terms. Right, so the xn, first term, second term, third term. Right, so second term and 100 term, nth term of sequence. Fine. So this is a if you look at now, let xn is equal to, now I am changing notation, right? Because initially I wanted to define what is sequence, so it is a function. So but now I have defined my notation key. I am denoting xn by x at n by xn, and therefore let xn is equal to 5n square minus 1 upon 7n, n in n. Right, so now I can understand what is a sequence. So what is sequence xn? sequence xn is 5n square minus 1 divided by 7n. This is my sequence. This is the notation, or sometimes in some books it is also denoted by 5n square minus 1 divided by 7n. So notation you can understand. This is round bracket, here curly bracket, meaning is same sequence. Right. So one way, because we have formula, direct formula for nth term, right? And from this, so what is 10th term of sequence xn, right? So you can understand what is a 10th term. What is a 10th term in this case? X10, right? And what is X10? In this formula, put n is equal to 10. So 5 into 10 square minus 1 divided by 7 into 10, and you calculate this number, whatever is the number, is 151st term. So you calculate this. Because why I am telling this nonsense things, because you can understand the later on how these terms behaves, that we want to understand basically, right? So you may feel that just to substitute n, but that is not straightforward sometimes. For example, let x1 is equal to 1 and x2 is equal to 2 and xn plus 2 is equal to xn plus xn minus 1 for n greater equal 1. N greater equal, no, what I want, xn plus 1 minus xn plus xn, so n greater equal 1. So now what is this suggest ki, is it defined at every natural number? Is xn defined at every natural number? First question, basic question. Yes.
Yes, sir.
Because for n is equal to 1 it is defined, for n is equal to 2 also it is defined, and for 3 n is equal to 1 we will get x3, right? So what is x3? What is x3? x1 plus 2, right? But what is xn plus 1, n plus 2? Xn plus 2 is the sum of previous two terms, right? It is sum of x1 and x2, that is 1 plus 2, which is 3. What is x4? Sum of previous two terms, sum of previous two terms. So x3 plus x2, and what is it? 3 plus 2, that is 5, right? So what is x5? So x4 plus x3, so 5 plus 3, which is 8, and so on. In this way you can calculate successive terms, right? So this is called as a recurrence relation.
So isn't this similar to the Fibonacci sequence?
Yes. So this sequence, this particular sequence is called as Fibonacci sequence. So and it is good exercise to see what is the significance of Fibonacci sequence. So this is a very interesting topic, right? So you can uh, read more about Fibonacci sequence, right? Because it has very interesting applications and significance. So, right. And also you think about what is golden ratio. So probably we'll discuss about this later on, right? Due to some reason, because it has something to do with convergence. And first we'll try to understand convergence of sequences. So what is a golden ratio? And golden ratio is an interesting topic, right? Okay, so you just, but I point is key, we can have the representation of sequence in this way, recurrence relation, in the form of recurrence relation. So if you know previous terms, you can predict next terms, right? And many physical problems or day-to-day life problems, if you formulate in mathematical model, you will get such kind of relations, recurrence relations, and then you should know how to deal with such relations.
Sir,
Yes,
x5 is x3 plus 2x2, right?
x5 is x4 plus x3, right? What is xn plus 2? What are the previous terms? xn, xn plus 1 and xn plus 2, right? So what is xn plus 2? The sum of previous two terms. You understand? Yes,
Okay, sir.
right. So what is xn plus 2? What is the previous xn plus 1? What is previous to that? Xn. And what is sum is xn plus 2. So if you know previous two terms, you can predict next term. Then you know this xn plus 1 and xn plus 2, you can predict xn plus 3 next term. Right. So if you know x10 and x11, you can predict x12. Right. In that way. And
Excuse me, sir.
yes.
Sir, is it correct to write like n greater than equal to 0 in this? Like we have mentioned, xn plus 2 equals xn plus xn minus 1. So, sir, is it correct to write n greater than equal to 1 because we can't find x1 from there, no?
Uh, that's why I have defined x1 and x2 separately.
Yes, sir, but actually we have written n for that
No, no, no.
term actually.
This is x1. First term is clear, 1. What is second term? 2. Right?
Yes,
Now
sir.
we are not, there is no confusion about first and second term. So what we are worried about? The third term onwards. And what are the third term onwards? Given by this, n greater equal 1.
Oh, okay, sir.
Right? So
Okay.
this is for xn plus 2. First and second term, we are not, no issue at all. They are completely in our hand.
Okay, sir.
Right. Fine. So let x1 is equal to suppose 1 and xn plus 1 is equal to 2 plus xn, n greater equal 1. So when I say n greater equal n, 1 means this is for xn plus 1. For what values of n I am defining xn plus 1? N greater equal, because x1 is already defined, no problem with x1. Right? So
Yes, sir.
now what is for second term? That means n is equal to 1, I will get second term of the sequence,
Root 3.
right? It is square root of 3. What is x3? x3 is
under root 2 plus root 3.
huh. So 2 plus under root of 3, correct? Am I right? 2 plus x2.
Yes, sir.
x2 is square root of 3 and so on. So x4 is square root of 2 plus
2 plus under
x,
root 2 plus under root 3.
right? So that means it is square root of 2 plus square root of 2 plus root 3. And so this expression becomes complicated, right? And you cannot, and if you increase the suffix, you increase the position where this tending, that we want to understand. That power we want to develop, right? Where it is going as your position increases. If x5, then there are many square roots. If x10, if you look at x100, then there are many square root signs. and how to understand this number, right? And where this is actually tending, what trend this pattern suggests, and where it is tending. So understand ki such phenomenon always occurs in our practical life, in economics, in everywhere, and we want to understand that trend, economical trend or whatever is. So that trend we want to understand means we want to understand where it is tending. Ultimately, how many terms are there? Infinitely many terms are there, but ultimately at n tends to infinity, your suffix xn, where it is tending. So what is the destiny, right? So what is where it will reach, that we want to understand, right? So suppose y1 is equal to uh, 2, y2 is equal to 2 by 3, and yn is equal to yn plus 2 is equal to yn minus yn plus 1 divided by yn plus yn plus 1. So then you can n greater equal 1, so you can understand the terms and you can write down successive terms of the sequence. So recurrence relation, right? Okay, so definition of sequence is clear, no doubt.
So, can I ask one thing? So,
Yes.
actually, the elements can be same in a sequence.
Yes, repetition is allowed. I am just, what is the definition of sequence? It is just a function, right? And in a function, you can map many elements to same point.
Yes, sir. Yes, sir. Okay.
Right.
Yeah.
So if I take A, B, C, and I take 1, 2, 3, this set, I will map A to 1, B to 1, and C to 1. Is it a function?
Yes, sir.
Yes,
Yes,
sir.
sir.
Every element of domain is mapped to unique element in B, right? So A is mapped to 1, 1 has unique position in B. So B is mapped to 1, 1 has, and C. So every element is. So this is a function. No matter how many elements are mapped to same point, that is not n. So same thing is applicable when I say a sequence is a function. Okay, so I will give you one more example. Right, so this is a sequence. Now we can understand the terms of this sequence. What are terms of this sequence? What are terms of this sequence? What is the first term?
Minus 1, 1, minus
Alternating
1,
minus
1.
1 and plus 1.
Right, these are the terms. But then, if I have sequence xn, which is minus 1 raised to n, can I say that my sequence xn is the set 1 and minus 1? Can I say this?
Yes, sir.
No.
So this is not, right? That is the difference between set and sequence. You understand? Because some position, see, the terms has to something to do with position. This minus 1 is assigned to first position, 1 is assigned to second position, minus 1 is assigned to third position. So positions, and this set is just two element set. Right?
Sir, so the elements doesn't have any relation with that sequence. It can be anything, no?
Element. See, if I define a function from natural numbers to real numbers, x of n is equal to minus 1 raised to n, then range of x, what is the range of this function? Range is 1 and minus 1. But range is not the everything about function, right? Range, if you know range, doesn't mean that you know everything about the function. Do you understand?
Yes, sir.
It's a range. But what is the sequence? The terms has, every term has its position, right? And therefore don't confused with set and sequence. So this is not true. Remember this. So what is the point? What is the point you should remember is this. Sequence is not same as the set 1 comma minus 1. This is a range of that sequence, but the terms have positions and therefore it is infinite process. Sequence is an infinite process because there are infinitely many positions and you are assigning numbers, right? Suppose you have, okay, let me give you an example. Suppose there are infinitely many, what you can say, students, infinitely many students sitting on chairs, infinitely many, suppose, and so on. And you want to label, and you have only two colors, red and blue, right? So what you will do, you will label blue, and then next you will label red, then next one you will label blue, next one you will label red, and so on. There are two possible labels. Doesn't mean that it does it mean that there are only two students or two chairs,
No, sir.
No.
right? There are actually infinitely many chairs, but we are labeling by two, right? Because what is our range? What is available with us? The only two colors are available with us, which is a range. But there are infinitely many chairs, right? So in that way you can relate philosophically. In a movie hall or in a theater or anywhere there are chairs and you want to distinguish chairs. So you can distinguish by numbers. But if you want to distinguish by colors, how many colors are available? There could be many chairs, but there are only finitely many colors available. So that is what this particular sequence minus 1 raised to n. There are only two possible numbers available for this sequence, and but positions are various. The chairs are various, many chairs, but possible colors also. That way you can understand it. So is it clear?
Yes, sir.
Okay. So and this, once you understand definition of sequence, okay, let us come to the example. Xn is equal to 1 by n. Now you understand 1, 2, 3, 4, and so on, and 1, 1 by 2, 1 by 3, 1 by 4, and so on. Positions and number. Now if you increase your position, where the numbers are going, where they are moving, what is the destiny, right? So if you see here,
Infinite.
so one first
They are
term is,
approaching zero.
so second, third term is 1 by 3, fourth term is 1 by 4, right? And here it is a simple situation, so you can understand where these numbers are tending, right? If you increase your position, then where numbers are tending, and ultimately they are tending towards zero, that we can understand. And therefore, what is the destiny for this sequence? What is the destiny for this sequence?
Zero.
Zero. But when suppose somebody is moving along this path, initially he is at 1, then he will go to 1 by 2, then in next step he will go to 1 by 3, in fourth step he will go to 1 by 4. Ultimately, where that person will reach? Do you understand? Where that person will reach?
Zero.
Zero. But when he will reach to zero?
Infinity. At
When that step will come?
so it won't come now because he'll go on and on.
Yes, that's why we are studying all these things, because in real life or in finite time it is not possible, but as a mathematics power we can predict. I am sure it will tend to zero. It will reach to zero when? After infinitely many years. Don't worry. Right? Here the situation is simple. That's why we can easily see ki it is going towards 0. But sometimes the terms are very complicated and it is very difficult to predict where it is ultimately reaching, where it is going. So for example, in previous example, xn plus 1 is equal to square root of 2 plus xn. Very difficult to predict by just observing where it is going, and so that power we want to develop. Do you understand?
Yes.
Yes.
Yes, so that power we want to develop. So what is that particular point? What is that particular position where these numbers will reach at infinity? At the infinity means where is the infinity? At the end of universe. At the end of universe, where it will reach? Right. So, let xn be a sequence of real numbers. So we say that xn converges. Xn is convergent. Okay, what I should say here. Okay, so what do from our previous discussion, what we want, what we are interested in, what we are interested in. So given a sequence, so where these numbers are tending, right? Where these numbers are going, that is called as a limit. What is the limit of this sequence? As n tends to infinity, as n tends to infinity means if you take infinitely many steps, and at the end where these terms will tend, that is a limit of sequence. So a real number x is said to be a limit of sequence xn if limit of sequence xn if. Okay, now the technical definition, classical definition, before going to classical definition, uh, how that definition is, that definition makes sense, that you need to understand first. Because when I say, or some books, author says ki this is a definition, why that definition, right? And I would like to talk about that, ki why that definition. Okay, just take this particular example. What is first term? The sequence xn is equal to 1 by n. Same example. Second term 1 by 2, right? Third term is 1 by 3, and so on. You know all the terms. Now, by observation, you said that, or many students said that this tends to 0, right? Am I right?
Yes.
Yes, sir.
Okay, so why it is going to 0? Means mathematically, or suppose forget about anything and you are thinking logically or mathematically, and how will you say that it is going towards 0? So that's how I am going to make the definition. Do you understand? How to say that it is going towards 0? Okay, let me give you a simple example.
So there is no value of n for which the value is lesser than 0.
There is a value of n for which 1 by n is less than 0, all n.
Sir, can we say that with each successive step, the number is getting smaller and smaller than its previous one?
Yeah, in this particular case, you can say this, but we want to make something general because here
Okay.
pattern is some simple pattern. Terms are going reducing, right? You
Okay.
understand? Please keep your mic off. Okay, so my problem is ki how to make something general. Okay, I will give you simple example. So, which everyone can understand. So, my position is time, and suppose you are going from Pune to Mumbai, right? You are moving from Pune to Mumbai, right? So, okay, now you are moving by car and somebody call you, okay, and you said that I am going towards Mumbai. Then your parents will ask you what is the proof you are going towards Mumbai. You understand? You said that 1 by n going towards 0, this sequence, what is the proof? Now the same problem I am asking, you are going towards Mumbai, what is the proof?
Location.
Yes. So my problem is ki your destiny is Mumbai. You are saying ki I am going towards Mumbai, right? So what will happen? Ki your position, that means at time t is equal to 1, you are at some place on highway, suppose, right, near Wakad, you can say. Those who are not from Pune may not understand, but some place near Pune. At time t is equal to 2, you are at, suppose, Lonavala, right? At time t is equal to, suppose, 20 minutes, whatever, you can understand this. So 10 minutes, so 3 minutes, 4 minutes, suppose I am at 10 minutes now, you are at some Khandala, whatever is. So, and as time passes, suppose time required to reach Mumbai is 2 hours or 120 minutes. At 100 minutes, after 100 minutes, you are somewhere near Mumbai. At 110 minutes, you are near somewhere here, right? Suppose your parents call you after 100 minutes, and what will be your answer? I am at Panvel, right? I am at Panvel. Suppose your parents call you and after 100 minutes, at 100 minutes you will say I am at Panvel. But does it sufficient? Is it sufficient that you are going towards Mumbai?
No.
You may take U-turn after that.
Yes.
So mathematically, see, this is a now mathematically, logically, how to prove that you are going towards Mumbai? You understand? Suppose after 110 minutes you are at New Mumbai, and is it sufficient that you are going towards Mumbai? You may take U-turn after that, right? So, what is a mathematical way to prove that you are going towards Mumbai? What will happen? What your parents will do? Your parents will say that okay, send me your location that you are from 100 1 by 10. Okay, so in practical it is very difficult, but you are 1 by 10 kilometers away from Mumbai. So this is a proper place, central position of place of Mumbai, and then m minus 1 by 10. Suppose you are in 1 by 10 kilometers away. Okay, let me make, before that, let me make some easier. So what your parents will do, your parents will ask, or parents or friend, whoever. So will ask you that okay, give me your location that you are in 1 kilometer away from Mumbai. Suppose this is 1 kilometer distance. then this is, and this is what proper place m, then this is m minus 1, right? Whatever is this m number, is a kilometer or whatever, this is m minus 1, and what is this, m plus 1. Do you understand this? This position is m plus 1, this position is m minus 1. Your parents will say that give me location, send me your location or time when you are in 1 kilometer distance from Mumbai. Then you will send location. Suppose you are here at this particular position and you will send your location. I am in 1 kilometer from Mumbai. Am I right?
Yes,
Yes.
sir.
But is it sufficient to say that you are going towards Mumbai if you send this location 1 kilometers away from Mumbai?
No,
You
sir.
may take, you may take that U-turn after that. So then your parents will not be satisfied. They will say, okay, send me location that you are from half kilometers from Mumbai, right? But that is also not sufficient because you may take U-turn after that. So send me location that you are from 1/100 kilometers away from Mumbai. That is not sufficient. So when mathematically, when the person will be satisfied that you are going towards Mumbai, you may given any distance from Mumbai, send me location that you are in that distance. Right? What I said, given any distance from Mumbai, whatever, if you can are able to send a location or you can give a location that you are in that distance from Mumbai, then ultimately what will happen? Do you understand? Then this will prove that you are going towards Mumbai. You have no chance of taking U-turn before Mumbai. Once you take U-turn from before Mumbai, there is a distance, right? So here it is Mumbai, and if you take U-turn from this position, then in this distance from Mumbai, you cannot send a location. Do you understand?
Yes, sir.
Right? And so what was my initial statement? Given any distance from Mumbai, if you can send a location in that distance, then you are going towards Mumbai. And if you take a U-turn before Mumbai, then there is a location. There is a distance from Mumbai. In that distance, you cannot produce a location. Do you understand? Is it clear?
Yes, sir.
Okay, so now
Yes, sir.
I want to make classical or more technical definition of the limit of sequence. Tell me what will be the definition. Exactly same example. You can read the definitions from books. That is not the easy job, or anybody can tell you definition. But why that definition? That is it appealing to you? Is that a proper definition? That is important. Can you tell me
A real
definition?
number is said to be a limit of sequence if all numbers between uh, near the that number are occupied by the sequence.
Yeah, in some sense you are saying is right. Suppose this is a destiny, or where you are claiming that I am tending towards this position, or sequence is claiming that tending towards. So suppose you as a mathematics student, you will tell somebody, your friend who do not know mathematics, and you say, you claim that this sequence going towards x, right? As like you are claiming that you are going towards Mumbai. Then your friend will ask you, what is the proof? What is the proof? Right? So you will say that you take, your friend will give you distance. Okay, you are saying that your terms are going towards x. I will give you distance. Can you produce the terms of a sequence in this distance from x? Right? Your friend will give you very small distance. Then also are you able to produce the terms of sequence which are in that distance from x? Do you understand?
Sir, so technically we can say that if our sequence is able to produce a number that is at an infinitesimally small distance from the given destination, then we can
Yes.
say that the sequence is tending towards.
Yes, but how to say this mathematically or more precisely, right? So definition means this is a precise way to say particular thing. So more precisely how to say this. So the sequence xn said to be x is said to be limit of sequence xn if given any distance from x, right? Do you understand? If this these are my terms of sequence and I am saying that that it is x is a limit, that means given any distance from x, we are able to produce terms of sequence which are in that distance from x. No matter whatever infinitesimal distance means whatever small distance you give, I can produce terms in that distance. Suppose somebody gives distance 1 upon 10 raised to 50, very small distance. In that distance also, that distance from x, I can produce terms of the sequence. Ultimately, what does it suggest? The terms are going very closer and closer to the x. What close? Give me any distance. I can give you terms closer in that distance. Do you understand this?
Yes, sir.
Right. So therefore, x is said to be limit of sequence xn if given distance, that means given epsilon means given distance, I can produce, okay, not n, I want to use something else. So I can produce k. K is a natural number such that the distance of terms of sequence from the x is less than epsilon for which for all n greater equal this particular k, right? Give me any epsilon, I can produce k. Give me any epsilon. Okay, let me explain this again. Why I am explaining this again and again? Because this is a very crucial point and the whole thing depends on this later on. So these are terms of sequence and x is somewhere here, and our claim is our sequence limit of this sequence is x, so it is going towards x. Means what? Means what? Given any distance from x, whatever distance, why I am taking epsilon? As the previous example, you are going towards Mumbai, your parents give you 1 kilometer, that is not sufficient. Your parents give you half distance, that is not sufficient. 1 by 4 distance, that is. So whatever distance is given, I can find a term, some particular k. This k is a particular, and suppose this is a x kth term, and this onwards, that means what are the onward terms? Xk plus 1, xk plus 2, all onwards, that means n greater equal k. Suppose k is 10, then what are the onward terms? X11, x12, x13, all after that, all terms are in epsilon distance from x. Is it clear?
Yes, sir.
Right. So give me any distance, I can produce k. That onwards, all terms are in that distance from x, and whatever distance you give me. If this going to happen, then we say that x is a limit of sequence x. Okay, so this is clear.
Yes, sir.
Yes, sir.
You think over it. Next time we'll work out examples, and then you can understand the exact meaning of this definition. Right. So you read this definition again and think over it. So we will stop here for today.